Welcome back, everybody, for another deep dive. This time we're going deep on Chapter 18 of this technical document all about asteroid mining.
Oh, yeah.
And it's not about getting to the asteroid this time.
Right.
It's about what happens
When you get there.
after you're there.
Yeah.
It's about moving the material.
The logistics.
Yeah, the logistics of moving all that rock and metal around in space.
Yeah, and it's often overlooked, isn't it?
Yeah.
People get really excited about the rockets and the lasers and all of that.
Sure.
But actually getting the stuff from point A to point B in the vacuum of space has its own challenges.
Yeah, you can't just call a space Uber.
No.
It's a logistical nightmare.
Yeah, even simple tasks become complex in the microgravity environment of an asteroid.
Oh, I bet.
Yeah, you've got to design tools and containers so that everything doesn't float away.
You mean you can't just, toss a wrench over your shoulder?
Well, you can, but you're going to be chasing it for a while.
Oh.
And then there's the fact that it's a vacuum, so any leak could be catastrophic.
Oh, wow.
Yeah, even just a dust particle.
Oh, really?
Getting into the wrong place
Oh, gosh.
could cause major problems.
It's making me think about, my vacuum cleaner at home.
Yeah.
You know how sometimes it, blows out the back a little bit of dust?
Oh, yeah.
And it's just a nightmare.
But
But then the other thing is the distance factor.
right, we're talking about moving massive amounts of material across interplanetary distances.
Oh, yeah.
So you need incredibly efficient propulsion systems.
This is like a nightmare move.
It is.
Cross country.
That's a good analogy.
Except there's, zero gravity and you're worried about radiation.
Exactly.
But how do they even hold on to all that material in space? It's not like you can just pile it up in a heap.
You can't just dig a hole and call it a day.
Right.
This chapter actually outlines some pretty interesting solutions.
Okay.
Like sealed containers for loose material, like high-tech Tupperware, but built to withstand the rigors of space.
Right.
And then for the valuable metallic ores, they're looking at magnetic containment, using magnetic fields to control the material.
Like those magnetic toys.
Yeah, kinda.
I used to play with.
But much bigger.
Except way bigger.
And hopefully less chaotic.
Yeah, and less flinging it across the room.
Yes.
So there's that, and there's also dust.
Yes. Dust is a major headache.
Really? I thought dust was the least of their worries.
Well, no, because fine regolith,
What's a regolith?
which is essentially asteroid
It's
dust,
asteroid dust. Okay.
it's a nightmare to contain.
Really?
Imagine trying to contain flour in your kitchen.
Oh, yeah.
It gets everywhere.
It really does get everywhere.
Now imagine that flour is abrasive,
Oh,
conductive,
oh, God.
and potentially dangerous if inhaled?
So it's like the worst flour ever.
Yes, basically.
Okay, so you've got this material, you've wrangled it into containers.
Yeah.
You've somehow kept the cosmic dust bunnies at bay.
Right.
How do we move all this to where it needs to go?
Yeah, that's where the real logistical puzzle begins.
I bet.
So for moving things around the asteroid itself, they're considering conveyor systems, hoppers, and even magnetic slings.
Magnetic slings. It's like a giant cosmic crane game.
Yeah, exactly.
That's how they...
Picture a magnetic arm swinging chunks of ore around and carefully depositing them where they need to go.
But what about getting the stuff off the asteroid?
Well,
We're not using slingshots for interstellar deliveries.
no, for those longer hauls, they're looking at things like orbital transfer vehicles or OTVs.
OTV.
Yeah.
So those are like the long-haul truckers of space.
Yeah, exactly.
I could already imagine the playlist.
That's on it.
Rocket Man walking on the moon, all the classics.
Nice.
What makes OTV so special, though?
Well, they utilize low thrust, but highly efficient engines like ion or Hall effect thrusters.
Right.
And this allows them to sip fuel
I like that.
while hauling massive loads over incredible distances.
Yeah, fuel efficiency is key.
It is.
Especially when you've got a cargo hold full of asteroid treasure.
Absolutely.
Now, the document also mentions electromagnetic launchers, too.
Oh, yes.
Those sound a bit more dramatic.
They're pretty impressive.
Is that the one with lasers shooting spaceships across the cosmos?
It's not lasers, but it's similar.
Okay.
Think of it like a giant railgun,
Okay.
but in space.
How does that even work?
Well, electromagnetic launchers use powerful magnetic fields to launch payloads into orbit. And this actually eliminates the need for any traditional fuel.
No fuel. That
Correct.
sounds like straight up science fiction.
It is pretty amazing.
But how do you launch something heavy with just magnets?
It's a complex process,
Okay.
but essentially they use a series of magnetic coils to accelerate a payload along a track,
Uh-huh.
building up incredible speed before releasing it.
So it's like a high-tech slingshot.
Exactly.
Except instead of rubber bands, we're using electromagnetism.
Yes,
Okay, I'm geeking out now.
as you should be.
Space railguns, fuel-sipping space trucks. This is way cooler than I imagined.
It's pretty neat.
But even with this tech, it's got to take some serious muscle to move an asteroid's worth of material.
It does.
How about the super heavy loads?
Well, for the truly massive hauls, there's an even more impressive solution.
Yeah.
Space tugs.
Space tugs?
Yes.
Okay, so we've got nimble space trucks.
Yes.
High-tech space railguns.
Yes.
And now heavy-duty space tugs.
It's a whole fleet of specialized space vehicles.
It is.
It is.
So once we've moved all this material, where does it all end up?
Well, that's where the bigger picture of space infrastructure comes into play.
Okay.
Imagine a vast interconnected network of space stations, Lagrange points, even lunar bases,
Okay.
all fueled by these mined resources.
It's like building a city in space.
It is. It's a complex system.
We're just getting started.
We're just beginning to imagine it, let alone build it.
Yeah, so from tiny dust particles to giant space tugs.
Yeah, we've covered a lot of ground,
We have.
haven't we?
Let's take a breath and pick up this cosmic journey in part 2,
Sounds good.
where we'll delve even deeper into the mind-blowing technologies that are making this space logistics dream a reality.
I'm looking forward to it.
Me too. This is cool.
It is.
I'm really excited about this.
Me too.
Okay, we'll be right back, everybody.
See you soon.
Welcome back to our deep dive into the world of asteroid mining logistics. So in part 1, we explored the Herculean task of just moving stuff around in space.
Yeah, it's not easy.
From containing that pesky asteroid dust to wrangling giant chunks of ore with magnetic slingshots.
That's right.
But now, let's turn our attention to the technology
Okay.
that could revolutionize how we move around the solar system.
Okay.
Remember that mention of nuclear thermal propulsion?
Yes, I do.
Get ready to have your mind stretched, because this is where things get really interesting.
Yeah, it's one of those technologies that sounds like it's straight out of science fiction.
For sure.
But it has the potential to make interplanetary travel significantly faster and more efficient.
So instead of relying on chemical propellants, nuclear thermal propulsion,
Or NTP for short,
NTP,
harnesses the power of a nuclear reactor to heat a propellant like hydrogen to extremely high temperatures. And this superheated propellant is then expelled through a nozzle-creating thrust.
Okay, so we're basically talking about a nuclear-powered rocket.
Essentially, yes.
That sounds a bit intense, to say the least.
It is powerful technology.
But what makes this better than the conventional rockets we're used to?
Well, for one thing, the thrust-to-weight ratio is significantly higher than chemical rockets.
Okay,
This means faster acceleration and shorter travel times,
got it.
which is a huge advantage when we're talking about journeys across the solar system.
Less time stuck in a cramped spaceship.
Exactly.
More time exploring those asteroid fields.
That's the idea.
I like it.
Yeah.
But what about safety?
Uh-huh.
I mean, nuclear reactors in space,
Right.
aren't those a bit risky?
Well, it's understandable to have concerns about nuclear technology, especially in space. But one of the key advantages of NTP is that the reactor only operates when the engine is firing.
Okay.
So during other phases of the mission...
Like coasting through space,
Exactly.
the reactor can be shut down,
Right.
reducing the risk of any potential incidents,
Exactly. It's like having an emergency shutoff switch.
just in case things get a little too hot.
Literally.
Literally. Yeah. But the chapter also mentions something called beamed power propulsion.
Oh, yes.
Now that sounds even more futuristic.
It does sound a bit like something out of Star Wars.
It really does.
But the concept is surprisingly grounded in science.
Okay, so instead of carrying all of its fuel on board,
Right.
a spacecraft using beamed power propulsion would receive energy from a remote source,
Exactly.
like a powerful laser
Right.
or microwave transmitter,
Right.
located either on Earth or in space.
That's right.
And this beamed energy would then be converted into electricity to power onboard systems.
Yeah.
Or used to heat a propellant generating thrust. Wait, so we're talking about sending concentrated beams of energy across vast distances to power a spacecraft.
It sounds ambitious.
It sounds incredibly ambitious,
Yeah.
not to mention a little bit terrifying.
I can see why you'd say that.
What if it missed the spaceship and hit something else?
Well, accuracy is a crucial aspect of beamed power propulsion.
Oh, I bet.
Researchers are developing sophisticated targeting and tracking systems to ensure the beam stays locked onto the spacecraft throughout its journey.
Okay.
As for the potential for unintended targets, the beams would be carefully aimed and controlled to minimize any risk to other objects in space.
Okay, that's reassuring.
Good.
But what's the advantage of beaming power as opposed to just packing a spaceship full of fuel like we do now?
Well, the main advantage is that the spacecraft wouldn't need to carry heavy fuel tanks, which means it could be much lighter and more agile.
I see.
This would allow it to reach higher speeds and travel greater distances, opening up new possibilities for exploration and resource utilization.
So instead of being weighed down by tons of fuel, we could send sleeker, faster ships across the solar system, propelled by beams of energy from afar.
It's an exciting possibility.
It's mind-blowing.
It is.
But let's shift gears for a moment and talk about another fascinating technology mentioned in the chapter. Swarm robotics.
Okay.
Yeah, this is where things get really interesting and maybe a little creepy.
It's a fascinating concept.
So imagine a coordinated swarm of autonomous robots,
Uh-huh.
each capable of carrying small payloads,
Right.
working together to move large amounts of material across an asteroid surface,
Okay.
or even between celestial
A
bodies.
very versatile system.
It's a concept that draws inspiration from nature,
Yes.
from social insects like ants and bees,
Right.
which are known for their collective intelligence and ability to accomplish impressive feats as a group.
Exactly.
So it's like a team of tiny space ants
I like that analogy.
carrying bits of asteroid treasure back and forth.
It is a very visual concept.
It is.
It is.
But why use a swarm of robots instead of just one big, powerful one?
Well, scalability and redundancy are two major advantages of swarm robotics.
Okay.
So if you need to move a larger object or a greater volume of material, you can simply add more robots to the swarm.
Okay.
And if one robot malfunctions, the others can easily compensate, ensuring the mission continues without interruption.
So it's like the power of teamwork,
Exactly.
even in space.
Even in space.
But wouldn't it be difficult to coordinate all those robots,
Well,
especially in the harsh and unpredictable environment of space?
that's where advanced algorithms and artificial intelligence come into play.
Okay.
Researchers are developing sophisticated control systems that allow the robots to communicate with each other,
Right.
adapt to changing conditions,
Okay.
and work together autonomously to achieve a common goal.
So it's not just a bunch of robots running around randomly.
Right.
It's a highly coordinated team capable of problem solving and adapting to unforeseen challenges.
Exactly.
That's pretty impressive.
It is a testament to the advancements in robotics and AI.
But before we get too carried away with these futuristic robots, let's not forget about the importance of making the most of what we find out there.
Good point.
The chapter also talks about integrating material transport with ISRU,
Yes.
or in situ resource utilization.
Right.
Can you break that down for us?
Sure. ISRU is all about making the most of the resources available on asteroids, moons, and planets,
Okay.
rather than relying solely on materials shipped from Earth.
Got it.
It's about using local resources to create fuel-building materials and even breathable air,
Wow.
reducing the need for costly and time-consuming resupply missions.
So instead of hauling everything we need from Earth,
Right.
we're setting up shop and using what we find out there.
Exactly.
That sounds incredibly efficient,
It is.
not to mention economical.
Absolutely.
But what are some of the key technologies involved in ISRU?
Well, one of the most promising technologies is 3D printing with regolith,
Okay.
the loose, unconsolidated material found on the surface of asteroids and other celestial bodies.
So like asteroid dust?
Yes, essentially.
Yeah.
So imagine using robotic systems to 3D print structures, habitats, and even tools directly on an asteroid using local materials.
It's like the ultimate in off-world recycling,
I like that.
taking what's already there and turning it into something useful.
Exactly.
That's way cooler than bringing a bunch of prefab stuff from Earth.
Yeah, and much more efficient.
But what about the really essential things like water and air?
Uh-huh.
Can we really create those from asteroid dust?
It might sound like science fiction, but the technology to extract water ice from asteroids and other celestial bodies is already being developed.
Oh, wow.
And this water can then be used for drinking, growing crops, and even splitting it into its component elements, hydrogen and oxygen, to create breathable air and rocket fuel.
Okay, now that's mind-blowing.
It's pretty incredible technology.
We're talking about creating the basic building blocks of life from asteroid material.
That's right.
This is truly next-level stuff.
It is.
But before we get too lost in the excitement of ISRU and all these futuristic technologies, let's take a step back and remember that all of this is happening in space.
Right.
A pretty unforgiving environment, to say the least.
It certainly is.
So what kind of engineering considerations go into designing the spacecraft that will actually be doing all this heavy lifting?
Well, designing spacecraft for material transport in space is a complex and demanding task.
Oh, I bet.
They need to be lightweight and fuel efficient to minimize launch costs and maximize range,
Right.
but also incredibly durable to withstand the harsh conditions of space.
Like what?
Extreme temperatures, radiation, micrometeoroid impacts.
Yeah, it sounds tough.
It is.
It's like building a car that needs to be both a race car and an off-road vehicle,
That's a great analogy.
all while being as light as a feather.
Exactly.
That sounds like a pretty challenging design brief.
It certainly is.
So how are they doing it?
Well, engineers are turning to advanced materials like carbon composites and lightweight alloys,
Okay.
combined with innovative structural designs to create spacecraft that are both strong and lightweight.
Yeah.
And, of course, propulsion is a key consideration.
Wow.
Even with advanced propulsion systems like NTP and beamed power propulsion,
Right.
the choice of engine fuel type and overall efficiency will be crucial in determining the capabilities and limitations of these spacecraft.
So it's not just about strapping a giant engine onto a metal box and calling it a spaceship.
No, it's much more nuanced than that.
It's about carefully balancing a whole bunch of factors
Exactly.
to create a vehicle that can not only survive in space,
Yes.
but also efficiently transport valuable resources across vast distances.
That's right.
And let's not forget about the cargo itself.
Good point.
How do you design a spacecraft that can handle everything from delicate scientific samples to giant chunks of asteroid ore?
Well, that's where clever engineering and modular design come into play.
Okay.
Imagine spacecraft with adjustable cargo bays, robotic arms for manipulating different types of materials, and
Right.
advanced containment systems to prevent spills, leaks, and contamination.
It's like designing a Swiss Army knife for space.
Yeah.
That's a great way to put it. Capable of handling a wide range of cargo types and transport scenarios.
Exactly.
Wow, this is really making me appreciate the incredible ingenuity and problem-solving skills of the people working in this field.
It's an exciting field to be in.
It's not just about rockets and robots.
Right.
It's about envisioning a whole new infrastructure for space.
Yeah.
One that's both efficient and sustainable.
Absolutely.
But we've covered a lot of ground in this segment.
We have.
From nuclear-powered spaceships to swarms of tiny robots.
It's been a whirlwind tour
It has.
of space logistics.
Let's take a breath and regroup in part 3, where we'll explore the even grander possibilities that lie ahead in the future of space logistics.
Sounds good.
Welcome back, space explorers. In parts 1 and 2, we really dug deep into the nitty-gritty of asteroid mining logistics.
Yeah, we did.
From, like, wrangling cosmic dust bunnies to harnessing the power of nuclear reactors and lasers to propel spacecraft.
It's quite the endeavor.
It's incredible. But now it's time to, like, set our sights on the horizon.
Okay.
And I'm not talking about just the asteroid belt. We're going to explore the truly mind-blowing possibilities of the future. A future where humanity expands its reach beyond Earth and establishes a permanent presence among the stars.
It's an exciting prospect, isn't it?
It really is.
We've explored the nuts and bolts, the challenges, and the incredible technology being developed to make asteroid mining a reality.
Right.
But the implications of this endeavor go far beyond just extracting resources.
Oh, I bet.
We're talking about a paradigm shift in how we think about space, not as a distant frontier, but as a potential home.
Wow.
A source of energy and materials and a catalyst for innovation and growth.
So it's not just about grabbing a handful of space rocks and calling it a day.
No, it's much bigger than that.
We're talking about building a sustainable infrastructure in space.
That's the goal.
A stepping stone to a future where humanity becomes a truly multiplanetary species.
Exactly.
That's incredible, and the first step on that journey might be closer than you think.
Oh, really?
The moon, our celestial neighbor,
Uh-huh.
holds vast potential as a hub for space-based industries.
Yeah, the moon is often overlooked,
Okay.
but it offers a lot of advantages.
Like what?
Well, for one thing, it's relatively close to Earth,
Yeah, that's true.
making transportation and communication easier and less expensive.
Right.
Plus, it has abundant resources like water ice, helium-3, and rare earth elements.
So we're talking about establishing permanent mining outposts on the lunar surface.
Exactly.
Extracting those resources to fuel further exploration and development.
That's the idea.
Hold on, the moon. Haven't we already been there and done that?
We have, but
What's so exciting about going back now?
the Apollo missions were a monumental achievement.
They were.
but they were just a glimpse into the moon's potential.
Okay.
We're now talking about a long-term vision,
Uh-huh.
a sustained presence on the lunar surface that goes far beyond planting a flag and collecting a few samples.
So what are we talking about here? Moon bases, lunar cities, a whole lunar economy built around mining and resource utilization.
Imagine a lunar base that serves as a launch pad for missions further into the solar system,
Okay.
a refueling station for interplanetary spacecraft,
Okay.
and a manufacturing hub for producing components and structures using lunar materials.
So it's like a stepping stone to the asteroid belt and beyond.
Exactly.
Okay, I'm starting to get the picture here. The moon is like our first pit stop on this grand cosmic road trip.
That's a great way to put it.
But the real treasure trove, at least according to this chapter, lies further out in the asteroid belt.
Right. The asteroid belt is like a cosmic gold rush waiting to happen.
I like that analogy.
But instead of gold nuggets, we're talking about platinum, nickel, iron, and even water ice.
Wow.
All essential ingredients for building a sustainable presence in space.
It's incredible. So instead of dusty prospectors panning for gold, we'll have space miners wrangling asteroids with lasers and robots.
It's a more high-tech version of the gold rush.
It's pretty epic, but the asteroid belt is a pretty crowded place.
It is.
How do we avoid bumping into things, or worse, causing some sort of cosmic fender bender?
Well, navigation and collision avoidance are critical aspects of any asteroid mining operation,
For sure.
especially in the asteroid belt, which is a dynamic and ever-changing environment.
Right.
Advanced sensors, powerful computers, and sophisticated algorithms will be essential for tracking asteroids, predicting their trajectories, and ensuring the safety of spacecraft and mining operations.
Like a giant cosmic game of billiards. Only the stakes are a bit higher when you're dealing with chunks of rock the size of mountains hurtling through space.
It's a high-stakes game for sure.
It is. So let's say we mastered the art of asteroid wrangling and resource extraction. What's next? Do we just load up our space trucks and haul all that loot back to Earth?
That's one option, but it's not the only one.
Okay, what else is there?
Imagine establishing permanent outposts in deep space, perhaps even on asteroids themselves. These outposts could serve as processing centers, refining raw materials into usable products,
Okay.
manufacturing components for spacecraft and structures, and even creating fuel for interplanetary journeys.
Hold on. Are we talking about building factories in space?
It's a possibility.
That sounds like something straight out of a science fiction movie.
It does sound futuristic.
But seriously, what are the advantages of manufacturing things in space, as opposed to just shipping everything up from Earth?
Well, for one thing, certain manufacturing processes could be more efficient or even impossible to achieve under Earth's gravity.
Really?
Imagine creating materials with unique properties, like super strong alloys or ultra pure pharmaceuticals,
Wow.
that could only be produced in the microgravity environment of space.
So we're not just mining asteroids, we're turning them into floating factories,
It's a possibility.
churning out products that would be impossible to make here on Earth.
It's an exciting prospect.
This is getting more and more futuristic by the minute. But as incredible as all of this sounds, I can't help but wonder about the implications of humanity expanding its reach so far beyond Earth.
Uh-huh.
What are the ethical considerations of mining celestial bodies and potentially altering these environments?
That's a crucial question, and one that we as a species need to carefully consider as we venture further into the cosmos.
Absolutely.
It's essential to approach space exploration and resource utilization with a sense of responsibility, ensuring that our actions are sustainable and that we minimize our impact on these pristine environments.
So it's not just about grabbing whatever resources we can get our hands on.
No, it's about being responsible stewards of the cosmos.
We need to think about the long-term consequences.
Yes.
The impact on these celestial bodies and our responsibility to future generations.
We need to develop international agreements and regulations to govern space-based activities,
Right.
ensuring equitable access to resources and preventing overexploitation. We need to prioritize sustainability, developing technologies and practices that minimize waste and environmental damage.
Right.
And perhaps most importantly, we need to foster a sense of global cooperation, recognizing that space is a shared heritage for all humankind.
It's clear that this journey into the future of space logistics is as much about ethics and responsibility as it is about technology and innovation. It's about balancing our ambition to explore and utilize space resources with the need to preserve these celestial environments for future generations.
It's a delicate balance, but one that we must strive to achieve.
Well, that's a pretty profound note to end on, from the challenges of moving material in microgravity to the ethical implications of building a space-based civilization. This deep dive into asteroid mining logistics has been a truly eye-opening experience.
It's an exciting field with so much potential.
It's a testament to human ingenuity and our unwavering drive to explore the unknown. And as we continue to push the boundaries of what's possible, who knows what incredible discoveries and innovations await us on this grand cosmic journey.
The future space exploration is full of
It
possibilities.
really is. So keep your eyes on the stars and your minds open to the infinite possibilities that lie ahead. Until our next deep dive, keep exploring.
See you next time.